Before I get started on this worksheet, two things. I am making this video from home, and anytime I'm home, my dog could be a bit of a disruption. I can hear her. She's chewing on something right now. Well, like something legitimate. She's got a chewy. But just know that you might hear her in the background, no big deal. And two, we're not going to spend a ton of time on complex rational expressions. I want to introduce the idea to you, but we're not going to do much more than that. Okay? So before we get started, we're going to look at just plain old fractions. Like we have for just about every other topic, we're going to start with fractions. So first, we have a definition. So the definition is for a complex fraction. So a fraction whose numerator or denominator, or both numerator and denominator, contain fractions is called a complex fraction. So that just means if you have something that looks like a fraction, and the numerator contains a fraction by itself or the sum or difference of fractions, and then the denominator contains a fraction or the sum or difference of fractions, you have what's called a complex fraction. So you could have something like this: a over b divided by c over d. That could be a complex fraction. You could also have something like a over b plus c over d all over e over f. Or you could have something like a over b plus c over d all over e over f minus g over whatever's next, h. Okay, those would all be considered complex fractions. So it's like fractions within fractions. Okay, now what we want to do is we want to simplify these complex fractions into either a single integer value or a single fraction. Okay, and in order to do that, we have to, one, find the LCD of all of the interior fractions. So look at the little pieces that make up the big complex fraction. All of those individual pieces, you need to find the LCD for those. You then multiply all of the different pieces by that LCD. In short, you're really just multiplying both the numerator and denominator by the LCD, but I show it a little more involved than that. And then we just want to simplify. Okay, so let's look and see what happens when we have to simplify a complex fraction. So for part A, we have 1/2 plus 1 over 6, all divided by 3/4 minus 2/3. Okay. When I say look at the interior fractions, I mean like the 2, the 6, the 4, and the 3. Those are the interior fractions. So we need to find the LCD, and we're going to be considering 2, 6, 4, and 3. Okay. So you've got different ways you can do this, and it just kind of depends on your understanding of LCD. Some people can just look at these numbers and just kind of know what the LCD is going to be. Some people have to sit down and do more work, and that's fine too. One way that you can do it that's sort of easy when you're dealing with just numbers is to look at the largest of the denominators. That would be 6 for us. So we want to start looking at 6 and then multiples of 6. So we want to first see, do the other denominators divide into 6? Well, 2 divides into 6, 3 divides into 6, 6 certainly divides into 6, but 4 doesn't. So we can't consider 6. So then we want to start looking at multiples of 6. So 6 times 1 is 6, 6 times 2 is 12. So then we start the same process. 6 certainly divides into 12 twice. 2 divides into 6, or 2 divides into 12 6 times. 4 divides into 12 3 times. 3 divides into 12 4 times. So all 4 of our denominators divide into 12, and that's the smallest number they're all going to divide into. So the LCD here is 12. Okay? So then my directions say multiply the numerator and denominator by the LCD. And that's fine, but I'll go ahead and just multiply each interior fraction by the LCD, just because for me it makes it easier to simplify. So I'm going to take 12 times 1/2 plus 12 times 1/6. That's basically multiplying the numerator by 12, but just distributing it through. And then for the denominator, I'm going to get 12 times 3/4 minus 12 times 2/3. And then we want to simplify. So let's see how each of these 4 pieces simplifies. So looking at the first half of the numerator, I have a denominator of 2 and an LCD of 12. Well, the denominator of 2 divides into the LCD of 12 6 times. So that leaves me with just 6 times 1 as my first numerator. Okay? And I'm going to switch colors for each of these so you can clearly see what's going on. For the second half of the numerator, my denominator of 6 divides into my LCD of 12 2 times, leaving me just 2 times 1. Then let's change colors again. Let's do green. For the first half of the denominator, my denominator of 4 divides into the LCD of 12 3 times, leaving me with 3 times 3. And then finally, let's do one more color. Let's try purple. The second half of the denominator, 3, divides into the LCD of 12 4 times, leaving just 4 times 2. So we're going to subtract 8. So that's how things are going to simplify. When you multiply all of these parts of this complex fraction by the LCD, things simplify beautifully. They simplify down very quickly and very easily. So then we just have to add or subtract what we have left. So for my numerator, I have 6 plus 2, which is just 8. My denominator, I have 9 minus 8, which is just 1, and that simplifies down all the way to just plain old 8. So looking at that initial complex fraction, you could never imagine we would get something as simple as 8, but getting from our initial complex fraction to our final answer was really quite simple by just finding the LCD and multiplying all of the parts of the complex fraction by that LCD. Let's look at part B. So part B, we have 3/4 divided by 3/5 minus 1. So we technically only have two denominators that we need to really look at, 4 and 5. So the largest of those denominators is 5. And I always start with the larger of the denominators and just kind of go through a list and see what divides into that and what doesn't. So 5 divides into 5, but 4 doesn't. Okay, so we would need to look at a multiple of 5. So 5 times 2 is 10. Well, 5 certainly divides into 10, but again, 4 doesn't. So the next multiple of 5 would be 15. Well, 5 divides into 15, but 4 doesn't. So we want to look at the next multiple of 5, which is 20. And that's the one that's going to work. 5 divides into 20 and 4 divides into 20. So the LCD here is 20. So just like in part A, we're going to multiply each part of this complex fraction by the LCD. So I'm going to take 20 times 3/4 in the numerator. And then I'm going to divide that by 20 times 3/5 minus 20 times 1. And even though that 1 in the denominator is not a fraction, it still has to get multiplied by the LCD. You're essentially multiplying the whole denominator by the LCD, and then you distribute. I'm just kind of showing that the distributive property already. So make sure all individual terms in the complex fraction get multiplied by the LCD. And then we can simplify. So looking at the numerator, the 4 in the denominator divides into the LCD of 25 times, leaving me with 5 times 3, which is 15. In the denominator, the 5 in the first half divides into the LCD of 24 times, leaving me with 4 times 3, which is 12. And then finally, we have minus 20 times 1, so that's just plain old minus 20. So we keep simplifying, and the numerator just stays 15. The denominator, however, is 12 minus 20, which is negative 8. So we could write it as 15 over negative 8, or negative 15 over 8, or negative 15/8. And I like this last one the best. So just know that no matter where you put the negative, as long as you have one negative, the whole thing is negative. So this is the version I like to see the most. All right, so that is simplifying complex fractions. In the next video, we're going to look at simplifying complex rational expressions, and the process is exactly the same. We just throw in some algebra.